What can you expect from a car of the next generation? You'd like space, comfort, and safety, but also a very economical engine delivering dynamic performance, while also being environmentally friendly. The developers of the TSI at Volkswagen have created an extraordinary engine which meets all these criteria. It's a compact engine delivering a power output of 125 kilowatt and 240 Newton-meters torque between 1750 and 5000 RPM and fuel consumption of 39.5 miles per gallon. A fusion of driving enjoyment and economy. Using TSI technology with dual charging, Volkswagen engineers have achieved the most uncompromising solution to date for both qualities in one engine. The engine design concept is optimized to reach maximum torque at low revs and to deliver it over a wide rev range. Conventional large engines come quite close to this goal. They stand for driving pleasure and comfort. The challenge for this development project was to combine large engine driving enjoyment with the economic advantages of small engines. The impressive achievement of the 1.4-litre TSI engine is in developing Volkswagen's FSI technology a step further in terms of driving enjoyment and efficiency. The engine achieves optimum fuel delivery by injecting fuel at 150 bar via new 6-hole injectors directly into the combustion chambers. The FSI combustion process takes advantage of the evaporation cooling effect to allow a high compression ratio of 10:1, despite dual charging. Previously, engines with high charge pressures had one limitation. The low exhaust energy at low revs causes so-called turbo lag. This is where dual charging comes into play. Volkswagen engineers have added a second charging component before the turbocharger, a high-speed, mechanically driven compressor. This effectively eliminates turbo lag. When high torque is demanded in the lower rev range, the compressor runs continuously. Dynamic compressor operation marks the transition to turbocharger operation. FSI technology and dual charging have been the key to successfully downsizing the engine. The combination of two advanced technologies. The two charging units in series make this the first high-volume production petrol engine to achieve charge pressures of up to 2.5 bar. This is a pressure level no conventional turbo engine can match. The schematic shows the air intake in the engine. Here you see the process at idling speed. If the driver now demands high power via the accelerator, the compressor is activated. An electromagnetic coupling, which is integrated into the coolant pump unit, connects and disconnects the compressor, which is driven via an additional belt. A high transmission ratio of 5:1 to the crankshaft enables the compressor to already deliver a pressure of up to 1.8 bar at idling revs. That means that the engine can, even when just pulling away, already deliver the desired high torque. In permanent operation, meaning within the range up to 2000 RPM, a high load demand will cause the control flap to close and the entire intake airflow will pass through the compressor. The compressor's high rotor speed has optimized engine responsiveness. In dynamic compressor operation, the automatic charge pressure control system determines, depending on the power demand, whether to activate the compressor or whether the turbocharger alone can supply the required charge pressure. If the charge pressure from the turbocharger is sufficient, the control flap opens and allows the direct passage of air to the turbocharger. The available exhaust energy is used to compress the charge air. The turbocharger has an inherent delay in response at low revs. Combining it with a compressor makes it possible to increase the efficiency of the turbocharger at higher revs. The functional diagram shows the air passing directly into the turbocharger. Tuning the two forms of charging to work in tandem in dynamic engine operation presented a special challenge for the engine's developers. When the engine revs drop back into the lower range and then power is demanded again, the engine management responds immediately. The compressor is activated again. The control flap closes, thus passing the air via the compressor. Above 3,500 RPM, the turbocharger switches to unassisted operation. When high power is requested, for instance when traveling at high speed, the turbocharger supplies sufficient pressure. The engine is now working in pure turbo operation. The air passes directly to the turbocharger again. The TSI is designed for engine speeds of up to 7,000 RPM. Thanks to the use of high temperature resistant materials, its fuel economy is outstanding, even at high vehicle speeds. Comparisons with other A-segment engines clearly show that the two development objectives have been fully achieved. An engine with high dynamic performance which, relative to its power output of 125 kilowatt, is extremely economical. The engine has been thoroughly tested to the toughest Volkswagen durability requirements. It successfully completed durability tests equivalent to 300,000 kilometers of driving. Over 250 prototypes and pre-production engines have been put through their paces in all required test cycles. Each individual engine component is designed for the engine's life cycle and has proved itself in crucial tests. For a high-performance engine like the TSI, all parts must be designed for continuous high loads. The crankcase, for instance, is made of cast iron and guarantees full working reliability, even at peak cylinder pressures of up to 120 bar. The engine is built with the latest instrumentation and high-quality components. Optimized production processes based on high-volume production technology for Volkswagen's proven small four-cylinder engine series. Highly qualified staff ensure fault-free assembly. Thus, Volkswagen's high-quality standard fully applies to this engine, built in Chemnitz. Since the torque curve is so steep, the driver is not forced to change gear too often. An exhilarating driving experience as the engine really comes into its own on winding roads and masters uphill stretches with an enormous burst of power. Driving enjoyment and economy, a successful combination realized with the high level of engineering you've come to expect from Volkswagen. That's why the Golf GT, powered by the TSI engine, is one of tomorrow's generation of cars.